Hi, this is Zach Anderson, and in this video I'm going to be going over Lab 4, Part 1. Without further ado, let's hop right into it. So we can see here that I'm on the lab instructions. I've already gone through and read all of these things, set up my system as however I needed to. So we can just hop right into it. Let's begin just with question number 1. Here I have my Wireshark capture, so we can go through this and see what correlates to what. So first, what is the 48-bit Ethernet address in my computer? So we can simply come down to this Ethernet 2 section. We see a destination and a source. So we come over here and we can find that our source is this. So this is going to be our 48-bit Ethernet address of D8EC5E03A7F9. Question number 2, what is the 48-bit destination? Same thing. We can just come to this destination part right here. And we see that it's 5C, A5, BC, C8, AD, CD. Is the Ethernet, the Ethernet address of the Gaia? No, it is not. It belongs to my router, which is the gateway. Question number 3, given the hexadecimal value for the 2-byte frame type field, what upper layer protocol does this respond to? So we can see this right here, 0x0800, and the protocol corresponds to the IPv4. Question number 4, how many bytes from the very start of the Ethernet frame does the ASCII G and GET appear in the Ethernet frame? So this was a little bit of math, but we calculated it to be 54, just some basic addition. Next, move on to question 5. So what is the value of the Ethernet source address? Is it the address of your computer or Gaia? So we can see that we're looking for the source address, which is going to be this here again. So D8EC5E03A7F9, and this is the address of my computer, and it's not the Gaia. Number 6, what is the destination address in the Ethernet frame? Once again, we're going to see the destination here, 5CA5, blah, blah, blah. Is it the Ethernet address of your computer? Yes, it is. 7, given the hexadecimal value for the 2-byte frame, what upper layer protocol? So this is the exact same value, so we're going to see 0x0800. And then in IPv4. Question number 8 is just a little bit later, so the ASCII O and OK appear in the Ethernet frame, so we calculated this to be 66. Next, we wrote down the contents of my computer's ARP cache, and we found that the first column value deals with the IP address of a device seen on a network, while the corresponding MAC address is the hardware address of the device. So we can now move on to the second part of part 1, I guess, which is going to be the ARP in action. Here we have the ARP capture pulled up, so let's begin. What are the hexadecimal values for the source and destination addresses in the Ethernet frame containing the ARP request message? So here we have the frame, and we see that the destination, let me expand this, so we see that the destination is D8EC5E, and the source is 5C, A5, BC, and the rest of it. Given the hexadecimal value for the 2-byte Ethernet frame type field, what upper layer protocol? So we see that the value is 0x0806, and the upper layer protocol for this is ARP. Number 1, how many bytes from the very beginning of the Ethernet frame does the ARP opcode field begin? Calculated this to be 20. 2, what is the value of the opcode field? So it's 1, which is just the ARP request. Number 3, does the ARP message contain the IP address of the sender? Yes, it does. Number 4, where in the ARP request does the message, or does the question appear? It appears in the target IP address field. So now find the ARP reply that was sent in response. Boom. How many bytes from the very beginning? So it's the exact same deal. We calculated this to be 20. The opcode is going to be 2, which is the ARP code for reply. Number 3, where in the ARP messages does the answer to the earlier ARP request appear? It appears in the sender MAC address and the sender IP address fields. Number 4, what are the hexadecimal values? So we see that for the source, we come down here, we see it's the D8EC5E, and for the destination, it's the 5C-A5BC. Now we can, for number 5, open the provide a file. Ultimately, why is there no ARP reply? And this is because there is no device on the local network that has the IP address specified in the ARP request for packet number 6. That should be it for part 1. Thank you for watching.